Hi guys, welcome to Brilliant Qatar. In this session, we are going to discuss the most important short questions from the chapter Hydrocarbons. You practice these 60 questions, okay? Total we are going to discuss 60 questions from this chapter Hydrocarbon. Practice the same questions again and again. Get full mark in Hydrocarbon chapter. You know, it's one of the important chapter in grade 11 and it's very useful for, or which a continuation is there in grade 12 also. Shall we start? Are you ready? Okay. Question number 1, they will ask you these type of short note questions, right? Write a short note on this type of reaction. Mostly they ask you Wurtz reaction, decarboxylation, ozonolysis, beta elimination, additionally Wurtz reaction, then pyrolysis, also called cracking, polymerization, aromatization. You know what are the main important reactions in this chapter, right? Like maybe Friedel-Crafts alkylation, Friedel-Crafts acylation, like that. Okay, so question number A is write a short note on Wurtz reaction. What do you mean by Wurtz reaction? In Wurtz reaction, two haloalkanes, what is mean by RX? Haloalkane, right? Haloalkane. In Wurtz reaction, two same haloalkanes are reacting with metallic sodium in presence of dry ether medium, right? Dry ether. In Wurtz reaction, two same haloalkanes join in presence of sodium and dry ether medium. Dry ether medium. What is going to happen here? The sodium take the halogen outside. Sodium take the halogen outside and this R and R, the two alkyl groups get joined, you will get RR. What is meant by RR? That is alkane plus the byproduct is what? 2NaX. So how you describe what is Wurtz reaction? When two same haloalkanes react with metallic sodium in presence of dry ether medium, it produces a even numbered alkane. Always that alkane having even number carbon and the byproduct is what? NaX. This reaction is called Wurtz reaction. So when they ask you to write a short note on one reaction, write the equation and the description about it. Okay. Number 2, we are moving fast. And what is mean by decarboxylation? Simply we can say it's a removal of carbon dioxide, but not the correct explanation. All of you check it. For example, I'm taking CH3COONA. Sodium salt of a carboxylic acid, you take it, okay? Sodium salt of ethanoic acid, let me take. And reacting with soda lime. What do you mean by soda lime? NaOH and CaO and heat. What is this? NaOH and CaO together, what you call? Soda lime. Okay? Soda lime. Soda lime. Ready? I'll give you a simple method how to write the product in decarboxylation. In decarboxylation, always the byproduct will be Na2CO3. Okay? Write the byproduct first of all. Na2CO3. Byproduct is Na2CO3. Then you write the product, main product, how to write? Simple. How many carbon in the sodium salt? 2 carbon, right? 1 and 2. And so your product is 1 carbon less alkane. Here you have 2 carbon in your sodium salt. Your product is 1 carbon less alkane. So 2 carbon here. What is your product? Methane. 1 carbon less alkane. Simply or similarly, if you taken sodium propanoate, starting, 3 carbon is there. So what is your product? Ethane. If you start with the sodium butanoate, what is your product? Propane. Like that. Okay. Always byproduct is what? Sodium carbonate. Okay. So how you describe it one? So when sodium salt of a carboxylic acid react with soda lime and on heating, it gives 1 carbon less alkane with byproduct Na2CO3. Number C part. What do you mean by ozonolysis? You may study that when an alkene react with ozone. When an alkene react with ozone, when an alkene to which if you add ozone, O3, you will get a ring compounds, right? That's called what? Ozonide. Ozonide. Which on treated with zinc and water, it break lysis. What do you mean by lysis? Breaking. The ozonide ring breaks and you may get aldehydes or ketone as a product. It's known as Ozonolysis. How we describe ozonolysis, dear? When an alkene reacts with ozone, it forms a ring compound called ozonide, which on reacting with the zinc and water, it's break and give you aldehydes or ketone. This is called ozonolysis. Number D part. Beta elimination. You know what is the other name of beta elimination? It's also called dehydrohalogenation. Dehydrohalogenation. What is the meaning of dehydrohalogenation? D mean removal. What? Hydrogen and halogen. Remove one hydrogen and remove one halogen from the compound. This is called beta elimination. For example, let me give you chloroethane. Okay, chloroethane. It's a haloalkene, right? Haloalkene. The reagent we are using for beta elimination is alcoholic KOH. Remember, dear. The reagent we are using for beta elimination is what? Alcoholic KOH. What you have to do in this one? You know, the halogen, the functional group attached to carbon is called alpha. Alpha connected carbons are called beta. Okay? Functional group attached to carbon alpha. Alpha connected carbons are beta. What you want to remove from this reaction? One halogen and one hydrogen. Verb. Halogen you cut from alpha carbon. One hydrogen you take from beta carbon. Get a double bond between alpha beta. Finish. So what is the product? CH2 double bond CH2. We will get alkene. So what is beta elimination, dear? When a haloalkane reacts with the alcoholic KOH, it forms an alkene. It's called beta elimination, also known as dehydrohalogenation. From where you take hydrogen and halogen, remember, halogen from alpha, hydrogen from beta, and get a double bond between alpha beta. Ready all? Question number 2. Write the IUPAC name of the product obtained by the ozonolysis. Ozonolysis is a sure question for exam. Okay, ozonolysis. Question number 8. Pentane. What is pentane? Pentane, I can write, this is the structure of pentane, right? 5 carbon, second position, double bond. What is the first step in ozonolysis, my dear? Add O3. Add O3, first step. Where actually we can add this O3? Very simple, the double bond. Reaction will take place. Addition always takes place on double bond, unsaturated side. Method, listen carefully. Cut the double bond. Cut the double bond. So what is left? CH3, CH, CH, CH2 and CH3. We cut the double bond. Ready? Now, in ozone molecule, in O3, how many oxygen atoms are there? 3 oxygen atoms, right? Add 1 above and 2 below. Place them. In O3, there are 3 oxygen. Place 1 above, 2 below. And connect with these 2 carbon. This ring structure, we call it as what? Ozonide. Okay? Ozonide. Now dear, listen carefully. Now we are going to treat with zinc and water. If you treat with zinc and water, it break like this. It break like this. How? I'll show you that. These 2 and these 2. Can you see what is there on left side? CH3CHO. CH3. Here, after the breaking, this C and O become double bond. Okay. This C and O double bond. This C and O also double bond. So we get CH3, CHO plus what is on right side? CH3, CH2, CHO. CH3, CH2, CHO. Ready? You will get ethanol and propanol as product. Maybe you get 2 aldehyde, maybe you get 2 ketone, maybe 1 aldehyde and 1 ketone. That's it. Let's give you another example. 3,4-dimethyl. Question B. 3,4-dimethyl hept. Hept mean how many carbon? 7, right? 1, 2, 3, 4, 5, 6, 7. 3,4-dimethyl. 3,4-dimethyl. Hept 3-ene. Hept 3-ene, right? 3,4-dimethyl hept 3-ene. Okay, let me complete the valency. It's already 4. Then it was CH2, CH2 and CH3. What is the first step in ozonolysis, dear? Add O3. How we add O3? Cut the double bond. Cut the double bond. So what is left? CH3, CH2, C. Just write this CH3 slightly left because we need to write the oxygen below. Okay. And this C. this C in which also one CH3 is there, then one CH2, CH2, CH3. And how we can add the oxygen? One above, two below. One above, two below we can write. Okay, now we are breaking. Now we are breaking with the help of what? Zinc and water. We are breaking with the help of zinc and water. How you break it here? These two bond. Can you say the product? CH3, CH2, C double bond O, CH3. We will get CH3, CH2, C double bond O, CH3. What is that called? Butane 2 on. And right side, CH3, CH2, CH2, C double bond O, CH3. We will be having CH3, CH2, CH2, C double bond O, CH3. We'll get pentane 2 on. This way we can write the ozonolysis product. And I hope you can try this also. Let me write C1, 1 phenyl bute. Bute means how many carbon? 4 carbon. 1 phenyl, bute 1 ene. Right? This one. Correct? Or this is the compound we have. This is our compound 1 phenyl, bute 1 ene. If it undergo ozonolysis, where we add ozone here, right? We will get benzene with CH, here CH, CH2, CH3. How we add oxygen? 1 above, 2 below. Just join them like this. And we can break it with the help of what? Zinc and water. If you break like this, what you get here? Benzene with the CHO. What is benzene with the CHO called? Benzaldehyde. And what is on right side? CH3, CH2, CHO. CH3, CH2, CHO. Propanol. Clear also, like any alkene if it given to in the same method. We are moving to the question number 3. An alkene A on ozonolysis, ozonolysis means what? First we will add ozone, second we will add zinc and water. It's giving you ethanol and pentane 3 on. What is ethanol? CH3, CHO. This is ethanol plus what is pentane 3 on? CH3, CH2, C double bond O, CH2, CH3. Right. So here already product is given. Product of ozonolysis already given. Right? They're asking write the structure and IUPAC name of this A. From which alkene we can prepare this one. Simple method. I'll give a shortcut method here. Can you see there is a CO group in both of the compound? CO group in both of the compound. Bring it close. What? The CO group, carbonyl group in both of the compound, bring it close. Okay, like this. For example, CH3, CH double bond O. Okay. Now I want to bring the CO very close. So C double bond O, in which what you have? One CH2, CH3 is there. One another CH2, CH3 is there. This is the compound. Can I write this one like this? Yes, right? Because our aim is bring the C double bond O group close. Bring the C double bond O group close. Okay, after that, cut and remove the double bond O part. Cut and remove the double bond O part and just add a double bond in between. So your product is CH3. So the reactant is double bond C, CH2, CH3 and here CH2, CH3. This is your answer. Can you name it the compound? You know, double bond has high priority. Number 1, 2, 3, 4, 5. 3-ethyl. What is the name of this compound here? 3-ethyl pend 2-ene, right? 3-ethyl pend 2-ene is the compound. We'll give you some more example. Listen carefully. Now here an alkene A contain 3 carbon-carbon sigma bond and 8 carbon hydrogen sigma bond and 1 carbon-carbon pi bond. 1 carbon-carbon pi bond. Okay. And this A on ozonolysis giving 2 moles of aldehyde. So the aldehydes are same one. So 2 moles of aldehyde with a molecular mass 44 U. For each of the aldehyde mass is 44 U. Write the IUPAC name of A. Don't worry, okay? We can discuss it. Carefully listen out. See, it contains total 3 carbon-carbon sigma bond. Okay, so let me write 1, 2, 3, 4. That only carbon-carbon 1, 2, 3, 3 sigma bonds. So total it contains 4 carbon. Then it's contain 1 pi bond also. 1 pi bond. So one double bond is there. Either you can place here or you can place here. I will place in the middle. Why? Because they said which on ozonolysis that's giving same compound, same 2 aldehyde. If you want to get same 2 compound, same product, the alkene should be symmetrical. Alkene should be symmetrical. Then only this will break, you will get to same product. Okay. So what is our compound is CH3, CH, CH, CH3. Our compound is but2ene. Let's try. This alkene is what? But2ene, right? First step is ozonolysis. How you add ozone? On the double bond side, right? So cut the double bond. What is left? CH3, CH, CH and CH3. 1 oxygen above, 2 oxygen below. Yes, we made the ozonoid. What is the ring called? Ozonoid. Now we are breaking with the help of zinc and water. Breaking these two sides. What is left side? CH3, CHO. CH3, CHO. What is on right side? Same one. CH3, CHO. Just to calculate one of the aldehyde mass, all of you. How many carbon? Okay, what is the mass? I'm just calculating. CH3, CHO. Correct. How many carbon in this compound? 2 carbon. So 2 into 12. You know, 1 carbon mass is 12. How many hydrogen total? 4 hydrogen. So 4 into 1. You know, hydrogen mass is 1. And 1 oxygen mass is what? 16, right? 16 into 1. Only 1 oxygen. So what is the total sum here? 24 plus 4 plus 16 is equal to 4. Here 44. So 44U is the mass of what? 1 ethanol. So here we are getting 2 ethanol. Ready? Next one. An unknown alkene A on ozonolysis giving 2 isomeric carbonyl compound. What do you mean by carbonyl compound? Here carbonyl compound means CO group. Okay. Carbonyl means CO group, means aldehyde, ketone, like that it's possible. 2 carbonyl compound B and C of the molecular formula C3H6O. Can you, I think we already get the answer. C3H6O, 3 carbon contain 1 aldehyde. Can you say propanol? What is that? Propanol. CH3, CH2, CHO, propanol. Check the molecular formula. C3H6O. And you know, aldehyde if the compound, its isomer is what? Ketone. Aldehyde isomer is ketone. So 3 aldehyde carbon is this one. What is the 3 carbon ketone? CH3, CO, CH3, propan 2 on. Aldehyde mean its isomer is which one dear? Ketone. With the same formula you can write only a ketone. Okay, so propanol and propanone is the 2 carbonyl. What is carbonyl means? They contain CO group. Okay, they are isomers also. And you know how to make the reverse calculation. Bring the CO group close, right? Bring the CO group close. Let me take this one. CH3, CH2, CH double bond O. First compound. And bring the CO group close. What is on this one? One CH3, one another CH3. What is next step here? Cut and remove this double bond O part. Add a double bond between. So your product is, or your answer is, this is the alkene. What is the name of this alkene here? You can number it from this side, right? You can number it from 1, 2, 3, 4, 5. 2-methyl pent-2-ene. 2-methyl pent-2-ene will be the answer. Are you getting or not? Okay, ozonolysis, sure question. Okay, take care. Question number 1. What effect does branching off? Okay, what effect on branching off an alkane chain has on its boiling point? You may study it. Boiling point is mainly proportional to molecular mass. Greater the molecular mass of the compound, greater the boiling point. Okay, first factor. Next one, boiling point is inversely proportional to number of branches. If the number of branches increases, boiling point of the alkane decreases. What is the reason? They're asking. Remember all of you, as number of branch increases, surface area decreases. What happened? Surface area of the compound, surface area decreases. When surface area decreases, there is a weak force of attraction between this alkane part. What? Van der Waals force. As number of branches increases, surface area decreases. When surface area increases, strength of van der Waals force decreases. As surface area decreases, the strength of the van der Waals force decreases. Force strength decreases mean boiling point also decreases. So, as number of branches increases, surface area decreases. Van der Waals force decreases. Therefore, boiling point decreases. Okay, remember that point. Number 7, draw the cis and trans. Sure question, cis and trans. Okay, any compound. Draw the cis and trans isomer of hexa-2-ene. What is hexa-2-ene here? First I am drawing hexa-2-ene normal structure. Okay, normal structure. This is for 6 carbon, 2, 4, 6, 2-ene. They are asking you cis and trans, right? Okay. If you want to draw cis and trans, immediately draw this one first, the base first, C double bond C. C double bond C. If they ask you to draw cis and trans, immediately draw C double bond C, C double bond C. Now fix the things, finish. These are the C double bond C carbon. What is there on left carbon dear? One hydrogen is there, one methyl is there. Let me place one hydrogen and one methyl. What is on the other carbon? One hydrogen and one propyl. Let me place one hydrogen and the propyl. Why I placed the hydrogen on the same side? That's what we call cis. Cis mean same group on same side. Same group on same side. Then how you draw trans of this one? Flip one side. Don't flip both side, okay? Flip any one side. So I can get H and CH3 here. We will get here CH2, CH2, CH3. Here one more H. Here H opposite. That's called trans. It's compulsory to know how to draw cis and trans of an alkene, okay? And one more, which isomer will have high boiling point and why? Please remember all of you, cis having high boiling point. Cis having high boiling point due to high dipole moment. Due to high dipole moment. Okay? If you draw the cis of this one, just check it all of you. Alkyl groups are donating group. So they will donate in this direction. This alkyl also donating group. So they will donate in this direction. The dipole moment is in this direction. So there is a high resultant dipole moment. Whereas here, this alkyl group given in this one, this alkyl given this one, there is some cancellation in dipole moment. So this one having cis having high dipole moment, therefore cis having high boiling point. Similarly, what about trans? Trans having high melting point here, high melting point due to high symmetry. Due to high symmetry. Please take care of the general factor. Generally, cis having high boiling point because its dipole moment is greater. Whereas trans having high melting point because of high symmetry. So remember, cis having high boiling point and low melting point. Trans having high melting point and low boiling point. Okay, don't forget. Number 8. How will you detect the presence of unsaturation in an organic compound? Bromine water test. Answer is BR2, bromine water test. What is the test here? Let me distinguish between ethene and ethane. Okay, ethene and ethane. Ethene is unsaturated, double bond is there, and ethane is saturated, correct? A unsaturated compound, when you react with the bromine water, bromine get added on this carbon, you will get CH2Br, single bond CH2Br. Okay, whereas saturated compound do not undergo addition reaction, no reaction. So here, how we distinguish? Bromine water color is reddish brown. bromine water color is reddish brown color. It's a reddish brown liquid. This reddish brown liquid, when react with the unsaturated compound, it becomes colorless. So if you can observe, the reddish brown color changes to colorless. What is the meaning? The compound is an unsaturated compound. Whereas if you added the bromine water to a saturated compound, still the color remains same as reddish brown, then it is saturated compound. Easy to identify. Number 9. Give the structure of an alkene. The alkene formula is C4H8. Okay, they said it's an alkene. 4 carbon, right? So but or prop 2-methyl propene, something is possible. Which add on HBr. What you are adding? HBr, H plus and Br minus, in the presence and in the absence of peroxide. So it's connecting with which topic? Markovnikov's and anti-Markovnikov's, right? You know, Markovnikov's rule in the absence of peroxide, the anti-Markovnikov's rule or Karash effect, which is in the presence of peroxide. Hope you remember. And but they are saying it's giving the same product. Normally, an unsymmetrical alkene react with HBr in the absence and presence of peroxide, you will get different product. But here they said you are getting same product, which means your alkene is symmetrical. Your alkene is symmetrical. Total how many carbon here? 4 carbon. 4 carbon. 4 carbon. It's an alkene, right? So let me write double bond in the middle. It should be symmetrical. Then only you will get the same product on Markovnikov. So what is this? CH3, CH, CH, CH3. Now you check it, all of you. If you add HBr, see these 2 double bonded carbon contain same number of hydrogen. Same number of hydrogen. It is symmetrical. So if you, what is actually Markovnikov's rule says that negative part of the addendum goes to carbon with less hydrogen, positive part goes to carbon with more hydrogen. Here no carbon with more hydrogen, less hydrogen, they contain same number of hydrogen. So if the alkene is symmetrical, if you add HBr in presence or absence of peroxide, we'll get the same product. You can add anywhere. H plus add to one carbon, Br add to other carbon. We will get CH3, CHBr, CH2 and CH3. This is the same product you get if you try with HBr, presence or absence of peroxide. Number 10, what happens when ethanol is heated with concentrated sulfuric acid at 443 Kelvin? You know, it's studied in 10th grade also. We know ethanol is CH3, CH2OH. When you heat it with concentrated sulfuric acid at 443 Kelvin, it undergo dehydration. My dear students, when an alcohol heated with a concentrated sulfuric acid at 443 Kelvin, it undergo dehydration. What do you mean by dehydration? Removal of water. How you remove water? Alcohol, right? OH, please take from alpha. Hydrogen you take from beta, get a double bond between alpha beta. So what is the product? CH2 double bond, CH2 plus water. How you dehydrated alcohol here? Take OH from alpha carbon, hydrogen from beta carbon, get a double bond between alpha beta. So ethanol on dehydration we get ethene. Okay, ethene. Number 11. Which one of the following exhibit geometrical isomerism? No confusion. Geometrical isomerism means cis-trans isomerism. Okay, cis-trans isomerism. Let's try the option or first one. 2-methyl propene. Let me draw the structure first. 2-methyl propene. 2-methyl propene. This is the compound. Let me draw the structure. Okay, what is cis-trans mean? We have to draw this one, right? These are the 2 carbon. What is there on this carbon? 2-methyl group. Okay, let me place 2-methyl group. What is on the other carbon? 2 hydrogens, right? 1 H and H. Can it show cis-trans isomerism? No. Why? There on 1 carbon, 2 groups are common. That's not the condition. In order to show cis-trans isomerism, both of the unsaturated carbon, 1 group should be common. Here on 1 carbon, methyl common, another carbon, hydrogen common. No. At least 1 group should be common in both of these carbon and they should be on the same side. That's called cis and trans. That's not possible. B option, but-1-ene. What is but-1-ene? This is what but-1-ene. Let me draw the structure. C double bond C. Okay. Which means these are the C double bond C carbon. What is on this left carbon? 2 hydrogen. What is on right carbon? 1 hydrogen and 1 CH2, CH3. Can you show cis trans? No, dear. Remember, out of the four group, if any 3 are similar, it cannot show cis trans. Out of the 4 group, any 3 are similar, it cannot. So you may ask like, sir, this H and H are on the same side, right? So it's cis, right? So I can say this H and H is here, trans also there. Cis and trans do not occur in a single structure. So out of the 4, if 3 are similar, they do not show. Okay. Number C, but-2-ene. What is but-2-ene? This is but-2-ene. Let me draw one of the structure. This is the C double bond C carbon. H and methyl is there. Okay, H and methyl. Right also H and methyl is there. Can you show cis and trans? Yes. This is cis because at least one group is common and they're on the same side. If you flip these two, you will get trans also. So C can. And what about D? 2,3-dibromo butene, right? Butene. 2,3-dibromo, right? Dibromo butene. 2,3-dibromo butene. Check it all of you. C double bond C. On this carbon, H and H. What on this carbon? 1 bromine and this group, right? This group, CH3, Br. Can you show? No, there is no common group in both of the double bonded carbon, so it cannot show. So they ask you, okay, don't forget the name. Geometrical isomerism means cis-trans isomerism. Number 12. Why butane? What is butane? CH3, CH2, CH2, CH3. Having more boiling point than isobutane. What is isobutane? CH3, CH3, CH3. This is called isobutane, or 2-methyl propane is also called isobutane. Why it having greater boiling point than the other one? They have same mass actually, but branching is the factor. You know, as branches comes, what happen? Van der Waals force decreases. So Van der Waals force decreases mean boiling point also decreases. So N-butane mean no branching, high boiling point. Here 2-methyl propane or isobutane have branching, so boiling point decreases. Number 13. Arrange the following in increasing order of boiling point. Number 1 is propane. Propane means CH3, CH2, CH3. Let me mark it A. Then B is butane. CH3, CH2, CH2, CH3. And C is 2-methyl propane. C is 2-methyl propane. 2-methyl propane. And number D is ethane. What is ethane? CH3 single bond, CH3. What is the first factor you have to check it about boiling point? Molecular mass. Which one having greater mass? Check it all. 3 carbon, 4 carbon, 4 carbon, 2 carbon. More number of carbon, more mass is for B and C. So B and C having greater boiling point. Okay. Among B and C, which one having greater boiling point? B, because no branch. So B the highest. After that, C. First factor mass, okay, then branch. So this one have B and C have 4 carbon. So that's having greater molecular mass, greater boiling point. Among these two, this one no branch, so high boiling point. So B greater than C. And what about propane and ethane? Propane, right? It's have more mass. So A, least one is what? D. Okay. So first factor mass, then branch. Next one. What are the conformations? What are conformation or rotational isomer or rotamers you studied? Yes. What is that? You know, ethane, right? CH3 single bond CH3. You have studied Sohols and Newman projection, right? What is Sohols? Sohols mean this carbon and carbon, we can draw a inclined line. On this carbon, 3 hydrogens are there, right? 3 hydrogens are there. Even the other carbon also 3 hydrogens are there. Here all hydrogens are face to face. This form is called what? Eclipsed form. Eclipsed form. And you know, the same, let me place first CH3 same. The other CH3 I'm rotating 180 degree. If you rotate 180, this H comes down. This H goes opposite, this H goes opposite. This is called the staggered form, right? Staggered form. What is this representation? Is called Sohor's, right? It's called Sohor's representation. Similarly, you have Newman also. Hope you remember Newman. So please study how to draw the Sohor's and Newman for eclipsed and staggered. And what is this isomerism? How you define it here? How you are getting this one? Because the carbon-carbon bond is rotatable. The sigma bond is rotatable. So how you define what are conformation? We can say compounds having same molecular formula but different spatial arrangement. Due to the free rotation of carbon-carbon sigma bond. This carbon-carbon sigma bond, when you rotate, you will get various structures, various spatial arrangement. They are called conformation. Once again, conformations means the molecules having same molecular formula but different spatial arrangement of elements or atoms due to the free rotation of carbon-carbon sigma bond, and it's called a conformation isomer or rotational isomer or rotamers. And draw and explain the different stability of conformation of which one? Ethene. Among staggered and eclipsed, you know which is more stable? Staggered, because the torsional strain is minimum. See, all elements are far away. All elements are far away, but here this hydrogen face to face, this hydrogen face to face, this hydrogen face to face, high repulsion. What is it called? Torsional strain. In staggered, torsional strain is minimum, therefore it is highly stable. So what is the order? You can say eclipsed one. In between, you know, there are different stages called skew form, and staggered is more. Staggered is the most stable structure because of less torsional strain. Eclipsed is least stable because of more torsional strain. Between eclipsed and staggered, lot of structures are there. They call it as what? Skew forms. Number 15. Draw different isomers possible for pentane. Okay. What is pentane? You may study it in 10th also. This is called N-pentane. Right? This is called N-pentane. Normal pentane. Let me write this name also. N-pentane. Mark it as compound A. How to draw the next isomer? Here 5 carbon in the straight chain, right? Let me make it 4 carbon in the straight chain and 1 carbon as a branch. These are the chain isomer. What is the name of this compound? 2-methyl-butane. Let me write B. One more structure is possible. 2,2-dimethyl. 2,2-dimethyl-propane, also called neopentane, compound C. These are the 3 chain isomers of pentane, and arrange them in increasing order of boiling point. They have same mass, right? Same mass. So check only branch. Which one having more branch? This one. So very least boiling point. It's have 1 branch, it's have no branch. No branch mean high boiling point. So A highest, then B least 1C. Greater the number of branch, more the number of branch, least the boiling point. Number 16. What is Baeyers reagent? Dear, Baeyers reagent is cold and dilute KMNO4. Cold and dilute alkaline or KMNO4 is called Baeyers reagent. Cold and dilute. You know how they express Baeyers reagent in your question paper is H2O plus O and KMNO4. They give you on the arrow. This is the way they mention Baeyers reagent. You know, cold and dilute, which mean water. KMNO4 is an oxidizing agent, okay, so oxygen, and KMNO4 they will written on the arrow. This is the way they mention Baeyers reagent. And what happens when butene react with, okay, let's see. When an alkene, for example, butene, okay, butene react with the Baeyers reagent. Baeyers reagent means what? H2O, O and KMNO4. I'll tell you a simple method, all of you. If they given you Baeyers reagent, okay, if they given you Baeyers reagent, please take 2 OH outside, means 2 alcohol outside, put it on the double bonded carbon, finish. If they given you Baeyers reagent, take 2 OH group, put it on the double bonded carbon, finish. So what is the product? CH3, CH2, CH, OH and CH2OH, okay? And the 2 OH group on adjacent carbon, they call it as what? Glycol. Glycol. You know, two halogens are on adjacent carbon, you call vicinal dihalide, right? Similarly, two OH on adjacent carbon called glycol. It's called butane 1,2 diol. So this is Baeyers reagent and its purpose. Put two OH group on double bonded carbon. Finish. Number 17. What is polymerization? What is polymerization? N number of monomer. Monomer means single unit. Many number of single unit monomer join, you will get a large giant molecule called polymer, and the process is called as what? Polymerization. Polymerization. So how we define polymerization? When n number of monomer join, we'll get a large number of, means a large giant molecule called polymer, and the process is called polymerization. Example, explain the reaction of polymerization of ethene, okay, not ethane one, ethene. Ethene, let me tell you. If you take ethene as a monomer, okay, ethene, how many ethene you have to take? N number, many numbers are there. Okay, if it undergo polymerization, I'll give a short method, not the real one, only for understanding how to write the product. CH2 double bond CH2, one ethene, CH2 double bond CH2, another ethene, like many numbers are there. I'll give a short method, not the real one. Just give these double bonds here. Means what it become there? CH2, single bond CH2, here one new bond. CH2, CH2, single bond, it's going on. Like many ethenes join, you will get a large molecule. But is it possible to write the entire thing? No, it's 1,000 lakh of molecules are there. So we can write like this one, CH2, CH2, this is actually the repeated unit, right? Write what? N times. This unit is repeated N times. This is called ethene. This is called ethene. This is called PE, polythene. Polythene cover and all, you know, right? So ethene undergo polymerization, we get polythene. Next question. Give reason for the acidic nature of ethine. Acidity is a very important question. Ethine, right? What is ethine? CH triple bond CH. Let me take let me explain completely, all of you listen. This is ethine, CH2 double bond CH2, what do you call? Ethene. Then CH3 single bond CH3, what do you call? Ethane, right? It's called as what? Ethane. Ethine, ethene, ethene, correct? Remember all of you, acidity is the factor. What is an acid? Acid is a substance which can donate H plus ion, right? Acid is a substance which can donate H plus. If it is easy to donate H plus, means it's more acidic. You know, alkyne carbons are sp hybridized, sp. Alkenes are sp2 hybridized and alkanes are sp3. Please study all. Alkyne carbons are sp. Alkene carbons are sp2. Alkane carbons are sp3. You know, in sp hybridization, 50% is the S character. In sp2, 33.3% is the S character, remaining 66.6 is P character. We want only S character. And sp3 mean only 25% is the S character. Remember all of you, acidity we are explaining by looking S character. What is that? So where is the high S character, my dear? Alkyne, correct? Higher the S character, not the point, okay? Higher the S character, more electronegative the carbon. So this carbon is more electronegative. More electronegative. What do you mean by electronegative? Ability to take electron, right? So you just, can you see there is a CH bond here? This carbon is more electronegative. So that will take the electron towards the carbon. So the H can leave easily. What is the point here? Higher the S character, more electronegative the carbon. So carbon pull more electron towards carbon and it can leave the hydrogen easily. Hydrogen remove easily mean more acidic. So it can donate this hydrogen easily. So it will be alkynes are more acidic. Then why alkene is less acidic? Because its S character is less. Carbon is less electronegative. It can't leave the hydrogen faster. So the order of acidity is alkynes are greater than alkene, then we have alkane, okay, alkane. The order of acidity is alkynes are greater. What is the reason, my dear? Alkynes having sp carbon. The sp carbon hydrogens are acidic in nature. Give you some more questions. Arrange the following in increasing order of acidity. Option A. I think this is easy, right? Let me mark it out, all of you. A, B, C. Already we said ethane, ethane, ethene. Which is more acidic? Alkyne. Which is alkyne here? A is more acidic. Then alkene, more acidic. C, then alkene. Okay, alkyne, alkene, alkene. Next, B question is very carefully, all of you, read it. CH triple bond CH, ethine. What is propine mean? CH3 C triple bond CH, propine. What is butadiene? CH3 C triple bond CCH3, butadiene. Here the problem, all are alkanes, correct? That's a problem. In previous question is easy. One is alkyne, one is alkene, one is alkane. We know the answer. But here all are alkanes. How to check? Very simple. You know which is sp carbon? The triple bonded carbons are sp. Which is the triple bonded carbon? sp, 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 sp. Triple bonded carbons are sp carbon. And sp carbon not enough. sp carbon not enough to get acidity, okay? Whether it contain hydrogen or not, you check please. This sp carbon contain 2 hydrogen, so it can donate 2 hydrogen. It contain only 1 hydrogen, dear, and this sp carbon no hydrogen. The one which can donate more number of hydrogen is more acidic, right? So which is more acidic? This, if you mark it as this is A, B, C, ethine is more acidic, then B more acidic, then C. So all are alkynes mean check the sp carbon, which means triple bonded carbon having more hydrogen or not. Okay, that's the point of acidity. One more question. Give a chemical test to support acidity of ethine. We want to prove that ethine is acidic. Very simple. Take ethine molecule once. Ethine. Let me treat with a metal called sodium. Why we treated with a sodium? You know, sodium is a highly reactive metal than hydrogen, correct? So sodium can displace hydrogen. If you displace one hydrogen, what you get? CH, triple bond, C, Na. C minus and Na plus. What it indicate? And it's remove what? One hydrogen also. It's not balanced, okay? Actually, 2 hydrogen. Generally, what the reaction shows that ethine molecule when you treated with, or alkyne when you treated with the sodium, sodium can easily displace the hydrogen because ethine is ready to give hydrogen. It's more acidic one. That's the thing. Next one. Explain cyclic polymerization of alkyne. Do you remember this reaction? One of the important reaction, right? Let me take ethine as an alkyne. Ethine. One ethine, second ethine, and third ethine. 3 molecules of ethine I'm taking and passing through. I hope when you're seeing the video, you're already saying that answer. Passing through red hot iron tube. Red hot iron tube at 873 Kelvin. 873 Kelvin. What happened? This double bond just to transfer this one. This is also polymerization. What is polymerization? Single units are joining. It's joining in a cyclic manner. Therefore, it's called cyclic polymerization. What you get, dears? This is nothing but benzene is the product, right? You will get a double bond, single bond, double bond, single bond, double bond, single bond. You will get benzene. So how will you convert ethine to benzene? That is what? Cyclic polymerization passing through red hot iron tube at 873 Kelvin. 22. Carefully listen all. An organic compound A with a molecular formula C3H4 on reduction with hydrogen and palladium. You know, hydrogenation gives an alkene B. Gives an alkene B. Okay. So what should be this one? It should be an alkyne. Yes or no? Because to alkyne on hydrogenation it become alkene. Ready. Then which on treatment with HBr forms an alkyl halide C. Forms an alkyl halide C. Alkyl halide. So dear, this is Markovnikov's rule. Yes or no? Markovnikov's rule, no peroxide. Okay, then C undergo Wurtz reaction. What do you mean by Wurtz reaction? Sodium and dry ether. It's giving a compound D Identify A, B, C, D. Easy, okay? Easy. Listen. What is C3H4? Only 3 carbon, right? Only 3 carbon alkyne. Which one? Propyne. What is propyne? CH3, C triple bond, CH. Propyne. Correct. To propyne, when you add hydrogen in presence of palladium, where you add this hydrogen? One here, one here. Propyne become propene. CH3, CH double bond, CH2. This is B, propene. Then, to which they are adding HBr without peroxide. So, let's apply Markovnikov's rule. What is Markovnikov's rule here? Negative part goes to carbon with less hydrogen. Positive part goes to carbon with more hydrogen. We get CH3, CH, Br and CH3. You will get 2-bromopropane. This is your compound C. Finally, it reacts with the Wurtz reaction. It undergo Wurtz reaction. How to write the product in Wurtz reaction? You know, Wurtz reaction means joining to same haloalkene. Correct. Let me take that compound, but I am writing in slightly different way. Please listen. CH3, CH, Br, CH3. Please check it all. This one, same or not? Please check. This compound, 2-bromopropane. Can I write like that? Why I draw in such a way? Otherwise, you will make mistake. And please, when you're doing Wurtz reaction, the halogen, right? Which is the halogen here, bromine. Please get the Br face to face because we have two same species. So let me take same one more compound. Br, CH, CH3 and CH3. So always when you do, in order to avoid mistake, always bring the halogens face to face. Okay? Then what you are adding in between? 2 sodium. Sodium take Br outside and this alkyl group join with this alkyl group. What is the product here? You will get CH3, CH, CH3, CH, CH3, CH3. You will get 2,3-dimethyl butane. So in order to avoid mistakes in Wurtz reaction, the given haloalkene, the halogen, right, face to face. Then cut them, join them. Ready. 23. Sodium salt of which carboxylic acid will be needed for the preparation of propane? Okay. We need propane. We need propane through decarboxylation. Yes, what is decarboxylation? Treating with a soda lime, right? Treating with a soda lime. So which carboxylic acid we can use here? You know, sodium salt of a carboxylic acid treated with the soda lime, you will get 1 carbon less alkene. So if you want to get propane, you have to use sodium salt of which acid? Butanoic acid. So answer is CH3, CH2, CH2, COONA. Sodium butanoate. We already said in the beginning what is the speciality of decarboxylation. Remember dear, always the product will be 1 carbon less alkane. 1 carbon less alkane. So if you want to get propane, the starter should be sodium butanoate. And don't forget the byproduct, okay? I'm just reminding you what is the byproduct always in decarboxylation? Sodium carbonate. Next one. Write the chemical reaction, okay? Next one. Write the IUPAC name of the product obtained by, sure question, Markovnikov, anti-Markovnikov. Pend1-ene. What is pend1-ene? Pend1-ene means this is the compound to which they are adding HBr first in the absence of peroxide. If you add in the absence of peroxide, let us apply which rule? Markovnikov's rule. What is Markovnikov's rule? Negative part goes to carbon with less hydrogen. Positive part goes to carbon with more hydrogen. So product will be CH3, CH2, CH2, CHBr and then CH3. Okay, Br come to this carbon. The same compound when you treated with HBr in the presence of peroxide, we will follow anti-Markovnikov's rule. What is anti-Markovnikov rule? Opposite. Negative part goes to carbon with more hydrogen, positive part to less hydrogen. So what is the product you get? CH3, CH2, 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 Br. Don't forget to study Markovnikov, anti-Markovnikov. No doubt, sure question. Then, 25. Why is Wurtz reaction not preferred for the preparation of alkene containing odd number of carbon chain? And illustrate your answer by taking one example. I told you, we are mixing always two same haloalkane in Wurtz reaction, correct? For example, let me take CH3Cl with the CH3Cl and sodium. You know, sodium, take the Cl out, methyl join, you will get ethane, right? Ethane. Ethane means what? 2 carbon, right? Always you get even number carbon. Why odd number is not forming like propane, pentane? No. Tell you, there is actually a limitation of Wurtz reaction. I'm taking two different haloalkane. This is same haloalkane, right? Different. I'm taking chloromethane with the chloroethane, okay? With the sodium and diether. Chloromethane and chloroethane. So you may think like, yes sir, this Cl cut, this methyl combined with ethyl, we get propane, right? It's odd number, right? Yeah, correct. But the problem is, if you consider this is the A compound and this is the B compound, if you mix A and B, you will get 3 products. How 3 products? You have different combination here. AA, AB, BB. How AA? Dear, chloromethane is a solution. Lot of chloromethane will be there. So one chloromethane react with another chloromethane. One chloroethane react with another chloroethane. One chloromethane can react with one chloroethane. So AA, AB, BB. 3 combinations are possible. What happened? One chloromethane react with another chloromethane. You will get CH3, ethane. What happened? Chloromethane react with the chloroethane, methyl and ethyl, you will get propane. What happened? Chloroethane react with another chloroethane, you will get butane. So you may think, still a odd number alkane formed, right? Then why the question is like that? Dear, you are getting this all product in the same beaker, in the same mixture. How you can separate it? As we discussed in classes, like if I am giving you tea, boost, Horlicks, everything in the same mixture, how you separate it? Yes, we can't separate them, right? So if all the 3 products are formed in the same mixture, we can't separate it out. So Wurtz reaction, always we are mixing to same haloalkane, then you will get only one combination, you will get a good product. Okay, take care. Now arrange benzene, okay, arrange benzene, N-hexane and ethane in decreasing order of acidic strength. They are decreasing order, higher to lesser. No worries, you know, alkynes are more acidic, right? Which is alkyne here, ethane. So C. Then alkene, which is alkene here, benzene. Then alkane, that is B. Why the order is like this? Decreasing order, right? Higher to lower. Next one. Why is benzene extraordinarily stable though it contains 3 double bonds? For example, I am taking a alkene ethene. These alkenes are highly reactive. If you add bromine or whatever the halogen and all, hydrogen and all, immediately it react and become what? Saturated, right? Saturated. So alkenes and alkanes, unsaturated compounds are highly reactive one. Even though double bond, you know, benzene is also alkene, right? It's having 3 double bond inside, but still, why it is not reactive much? That's a question. Generally, alkenes are highly reactive. Benzene is an alkene, but it do not undergo addition reaction faster. Why? You know, dear, benzene in which resonance is possible. Benzene in which what resonance is possible. Right? Benzene in which resonance is possible. You know, resonance makes a compound more stable. So benzene is a resonance stabilized compound. So it do not undergo addition reaction faster. Okay, faster. Number 28. What are the necessary conditions for any system to be aromatic? We study if the system want to become an aromatic compound, it should obey which rule? Haeckel's rule, right? Haeckel's rule. If you want to say that this compound is aromatic, this compound should obey Haeckel's rule. The 3 rules are there. What is first rule? The compound should be planar and cyclic. The compound should be planar and cyclic. and the compound should contain 4n plus 2 pi electrons. Hope you know it. The compound should contain 4n plus 2 pi electron. N is whole number, n can be 0, 1, 2, 3, etc. And finally, the compound should be in resonance, which means delocalization. There should be a delocalization of pi electron, means the compound should be in resonance. So in order to obey Huckel's rule, or the compound want to be aromatic, 3 rules should be obeyed. Number 1, compound should be planar and cyclic. Compound should contain 4n plus 2, put in bracket, pi electrons. And the compound should be in resonance. And 29, explain why the following systems are not aromatic. Give you a system here, NCERT question. Why this compound is not aromatic? We want to prove it. Number 1. What was the first condition for Huckel's rule here? The compound should be cyclic. Is it cyclic or not? Yes. Is it planar? How to check planar? You check it. All carbons are sp2 or not. sp2 means trigonal planar. Yes, all double bonded carbons are, we know, sp2. So all first condition is okay. First condition is okay, because it is planar and cyclic. And what is the second condition? The compound should contain 4n plus 2 pi electrons. What do you mean by, I told you what is the n value possible, right? Here n value can be 0, 1, n can be 2, n can be 3, etc. Whole number. Just to count all of you. If the n value is 0, how many pi electron will be there? 2 pi electron, correct? If n is 1, 4 plus 2, 6 pi electron. If n is 3, it will be 10 pi electron. If n is 2, if it is n is 3, it will be 14 pi electrons. 14 pi electrons. And etc. How to check whether this rule is obeying or not? Very simple. In which how many pi bonds are there? 1, 2, 3, 4. 4 pi bond contain how many pi electron? You know, each bond contain 2 electron. There are 4 pi bonds, so it contains 8 pi electron. 8 pi electron. Is it there in the system? No. Remember this number, okay? 2 pi electron, 6 pi electron, 10 pi electron, 14. That is aromatic. 8 pi electron not in our system, so it's do not obey this 4n plus 2 pi electron rule, so it's not aromatic. Okay, not aromatic. And check another compound I am giving you, this one. Prove that why it is not aromatic. All are NCERT question. Why it's not aromatic? Here, first check whether it is cyclic or not. Yes, cyclic. Is it planar? Check the hybridization. Double bonded carbons are sp2, my dear. sp2, sp2, sp2. But can you see there is an upper carbon? It's single bonded carbon. Single bonded carbons are sp3, not planar. sp2 are planar, sp3 not planar. So since it's having sp3 carbon, it's not planar, so it's not aromatic. Here, the second rule is violated. Here, first rule is violated. Okay, check it out. Next question. Very carefully read it all of you. Lot of reaction we are bringing here. An alkyl halide, okay, when an alkyl halide or haloalkane with the formula C5H11Br, this is your compound A. Make a reaction chart first. It reacts with the ethanolic KOH. Yes, what do you mean by ethanolic KOH? Mean alcoholic KOH, okay? Alcoholic KOH. It's giving an alkene B. B is a alkene. What is alcoholic KOH mean our reaction? Beta elimination or dehydrohalogenation. And the B react with the bromine to give a compound C, which on dehydrobromination. Dehydrobromination means removal of hydrogen and Br, right? It means beta elimination only. It's giving a compound D alkyne. Okay, alkyne. On treatment with a sodium metal, in liquid ammonia, 1 mole of D gives 1 mole of the sodium salt of D. You are getting a sodium salt of D plus and 1 mole of hydrogen gas. Okay, H2 gas. Complete hydrogenation of D. D on complete hydrogenation yield a straight chain alkane. A alkane in straight chain. Okay. Identify the compound A, B, C, D. All of you, symbol all. Okay, now by looking the size of the structure and all, or the question and all, don't judge it. It's tough or no. Total how many carbon in your haloalkane? 5 carbon, right? Let me make a trial method. 5 carbon. Okay, let me write CH3, CH2, 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 Br. One more carbon, right? Total 5 carbon. CH2, Br. I'm taking the compound 1-bromopentane. I'm just trying, okay. Total 5 carbon is there. So 5 carbon is pentane, in bromine is there. So it's 1-bromopentane is the compound. If it undergo beta elimination, dears, hope you remember what is beta elimination. What is beta elimination? Remove halogen from alpha, remove hydrogen from beta, get a double bond between alpha beta. So what you get? CH3, CH2, CH2, CH double bond, CH2. You will get pentene. Now they are adding Br2. What happens if to an unsaturated compound, if you add bromine water, then bromine get added here and here, right? So we will get the product next one, CH3, CH2, CH2, CHBr and CH2Br. Ready. Next reaction. Take it. Next reaction is they are doing dehydrobromination and getting an alkyne. What is that? We studied in our preparation of alkyne from vicinal dihalide. This is a vicinal dihalide, my dear. If you do beta elimination twice here, both of the halogen goes and hydrogen also, and you will get a triple bond there. Okay, you will get CH3, CH2, CH2, C triple bond, CH. A vicinal dihalide, if you do 2-time beta elimination, you will get a triple bond in between. That is called preparation of alkyne from vicinal dihalide. Now, this is your compound D. This compound treated with sodium. Yes, we studied. Alkynes are acidic in nature. It can leave the hydrogen faster. So, this sodium displaces this hydrogen because this hydrogen is acidic. So what do you get? CH3, CH2, CH2, C triple bond, CNA. Na plus will remove the H plus. And what they already said, 1 mole of hydrogen. It's not balanced, okay, not balanced one. So this hydrogen is get removed by sodium, okay. And one more thing they given. So this is your compound A, this is your compound B, this is your compound C, and this is your compound D. And one more thing they said, this alkyne on complete hydrogenation, it forms alkane. What is complete hydrogenation mean? To an alkyne, when you add 1-time hydrogen, it become alkene. 2 hydrogen, it become alkene. So let me add 2 hydrogen in presence of nickel platinum. The triple bond becomes single bond. So what is the product? CH3, CH2, 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 CH3. You will get pentane. Yes, it is a straight chain alkene. So your compounds are 1-bromopentane, pentene, 1,2-dibromopentane, pentine, and last one pentane. So try this question carefully. Lots of reaction we can connect to this one. So now we are completing our part 1 session of hydrocarbon questions. Hope you all covered majority of the reactions we covered. Wait for the part 2 in which we are going to study full conversion questions in which you can understand lots of the minute reactions, etc. Everything we'll discuss there. Just wait for part 2. See you there.